Hello class, today we're going to talk about section 5.4, which is solving compound inequalities. By the end of today's lesson, you will be able to solve and graph inequalities involving the words and or. A compound inequality is an inequality that has two separate pieces to it, and they're either connected by and or. If they're connected by the word and, we call this an intersection. And the solutions for this problem only work if it is true for both statements. So if it is, if you plug it in, if it works for both of them, then it's okay. The union, on the other hand, is connected by the word or, and the answers are okay as long as it works for at least one of the problems. It may work for both inequalities, but it only has to work for one. So, when we're looking at intersections, or those ones with and, we're going to put this on the graph. Our first one is x is greater than 3. So if I test with 0, 0 is greater than 3 is false. So I'm going to put 3 with an open circle, and moving to the right. And then we've got on the other one, 0 is less than or equal to 7, which is a true statement. So I'm going to go over to 7. I've got my closed dot at 7, and that arrow is going to the left. Because we are looking for the intersection, or the and, we are looking for the overlap. So the only answers to that problem are in the overlapped blue shaded area. So when you're solving these problems for homework, you're going to either need to highlight that intersection part or the overlap part, either that or make it a darker version of your pencil or pen, whatever you're using. But you need to somehow indicate that this overlap part is what you are actually concerned about for your answer. The rest of it, so this part over here and over here, only work for one of the two inequalities. So we need it to work for both, so that and part, the overlap, is the blue. This is another way that you will see intersections formatted, written out as one whole inequality. When you are solving problems like this, you are still going to take the 7 away, but you have to do it to both of the other numbers. You could think about it as breaking the inequality into its two pieces. 6 is less than r plus 7, and r plus 7 is less than or equal to 10. So we could break it into its two pieces and solve, or we can leave it as it's written up top and solve from there, just making sure you take the 7 away from both sides of the equation. So once I take that 7 away, I end up with an answer of -1 is less than r, which is less than or equal to 3. So when I'm testing here, I'm going to have to test for the two pieces. So -1 is less than 0 is a true statement, and 0 is less than or equal to 3 is also a true statement. So when I put my -1 as an open dot and 3 as a filled in dot, I've got my arrow out of -1 going to the right, my arrow out of 3 going to the left, because we want both of them to go over 0. So that intersect part is the part where they overlap. Go ahead and try this one on your own, solving and graphing the inequality. Adding 3 for both of the inequalities, you end up with y is greater than or equal to -8 and y is less than or equal to -5. Putting those graphs on this number line, we end up with that red area of overlap. If you have questions about the intersections, please let me know when you get to class. The other thing that we're looking at is the union, or these inequalities that are connected with the word or. Again, if we're doing this simple form, we're going to plug in 0 to test. 0 is greater than 2 is a false statement. So I've got my open circle at 2, and we are moving to the right. Then I come over and I test the second one. 0 is less than or equal to -1. Again, that is a false statement, so I have my -1 filled in circle going to the left. This is all that we need to graph here because answers can work for either the first part or the second part. So the only numbers that actually don't work as answers are what would be in between here. So for example, we plugged in 0. 0 was false for both of them, so it didn't work. If I pick out the number 10, for example, from way over there, I got 10 is greater than or equal to 2. That's true. So we are done. 10 works as an answer. If I pick out -5, for example, -5 is not greater than 2, but -5 is less than 1. So that's why this part over here works as well. So if we are solving and graphing, this first one doesn't actually need any solving. So I've got 0 is less than or equal to 9 is a true statement. So I've got my point at 9. Oopsies. True statement. So we are going to the left. The other inequality we're actually going to have to solve. So I subtracted 2 and I get 4b is less than 8. Dividing both sides by 4, I end up with b is less than 2. So I'm going to put my circle at 2. Test 0. 0 is less than 2. And that is also moving to the left. Now, there is intersection or overlap here, but that is not the only solutions to the problem. The answers over here, where there is no interlap, would also work as well. So for example, the number 7, because it works for this first inequality, is part of the solution. So there's no extra shading when you are doing unions. Go ahead and try this one on your own. First one, you get an answer of y is less than 3. So that's the open circle going to the left. Or second option is a is greater than or equal to 7, so that's that closed dot going to the right. If you have questions about this, please let me know when you get to class. Word problems. So we have a company makes action figures that must be at least 11.2 centimeters and at most 11.6 centimeters tall, graphing the inequality. So when we have that phrase, at least, that was we want it to be bigger than or equal to. So we want bigger than or equal to 11.2. It gives us the word and, so that means we have an intersection. At most, so it's got to be smaller than or equal to 11.6 centimeters. So I'm going to change this center point and make that 11.0 so I can keep counting by ones. So I'm going to come over to 11.2 and I'm going to test that and say 0 is greater than or equal to 11.2, which is false. So that's going to the right. And then if I come in and test over here, 0 is less than or equal to 11.6 is indeed a true statement. So I've got that going to the left. And because it's an and, we want to highlight that overlap. Go ahead and try this one on your own, paying careful attention that you are looking for what sounds humans cannot hear. So, when we are looking at this, when we want the things that they can't hear, that's anything below 20, so x is lower than 20, and what they can't hear on the higher end is greater than 20,000. That is an or situation, because we are looking for what they can't hear. The and part is in between with it, which is what they can hear. I renumbered going by 1,000, putting that 0 down at the end. If you renumbered differently, that is totally fine. If you have questions about this or anything else from the lesson, please let me know when you get to class.